11.7, probability with and. First of all, we're going to talk about independent events. Here's a formula, probability of A and B. We have two different events happening, and we want to know the probability of both happening. We just simply multiply P of A times P of B. By independent, we mean what happens with A has no impact on B. And these three examples will bear that out. First of all, we're going to roll a six-sided die twice and find the probability of rolling a 2, then a 5. You will recall that the sample space for a six-sided die is that, the numbers 1 through 6. Probability of rolling a 2 is 1 out of 6. Probability of rolling a 5 is 1 out of 6. So you get 1 out of 36. 1/36 of the time you will have that outcome. Now, these are independent because a die has no memory. We roll it, it's a 2, it does not remember what happened. The first roll has no impact on the second. These are two totally independent events. 2 6s, well, the first 6 is going to be 1 out of 6. And the second 6 is 1 out of 6, and it's 1 out of 36. So, another example, we're going to draw a card from a 52-card deck, replace it, and then another card is drawn. Find the probability of drawing a 10, then an 8. Well, a 10, there's 13 different cards. There's 4 10s. You can do 4 out of 52, or you can just do 1 out of 13. 4 over 52 reduces to 1 out of 13, and of course 8 again is 1 out of 13. Ace through 10, Jack, Queen, King makes 13, and we can do 1 out of 13 again, and we get 1 out of 169. If you do 4 out of 52, you just end up with a ginormous number that can be reduced to 1 over 169. 2 diamonds, same thing here. There are 13 diamonds out of 52, but we can just consider the sample space of diamonds, clubs, hearts, spades, 4 items. Diamond is 1 out of 4 times 1 over 4. Now you draw it and replace it, and presumably we're going to shuffle it up, and the card we draw on the first draw will not influence the card we draw on the second draw. So that's why they're independent events. A fourth of a fourth is 1 over 16. Now, if we drew a card out, kept it out, and drew a second one, then of course, if you drew a diamond on the first outcome, you have less diamonds on the second. That would influence the second one. A coin is flipped twice. Find the probability of getting 2 heads. Heads, tails, 50-50. 2 equally likely outcomes if it's a fair coin. 1/2 times 1/2 is 1/4. And then heads, then tails. 1/2 times 1/2, which is 1/4. And incidentally, that's exactly the same as if we write the sample space HH, HT, TH, TT. There are 4 equally likely outcomes. Okay, 2 heads is right here. Heads then tails is right here, 1 out of 4. Now, if we wanted a heads and a tails in any order, then we have 2 possible outcomes, so it would be a half. Or you could figure this quarter, you could do it the other way around, add it together. They are mutually exclusive events. A quarter and a quarter adds up to be a half. If we did you could do this by problem number 2 of the sample space, but it would just be huge. It'd be too difficult to write it out. Rolling 2 die, we've actually seen the sample space for that. There's 36 different outcomes. There's one of them, there's another one. So you can definitely do this 2-stage experiment as one sample space that gives you the exact same answer. So Okay, that's all for independent events. We'll be back with a couple examples with dependent events shortly.